G'day mate, today you're going to be talking to yourself about complex numbers. Now you mentioned the last one that complex numbers, it was actually written here, imaginary numbers were made up numbers used to operate on the realm that is not captured by the real realm. For example, square root -1, not a thing, you know this, yes? Complex numbers are defined by this, where A and B are both an element of real. Now, this is basically algebra where A and B are constants, and I is a pronumeral. There we go, you got it in the end. So, when you say Z1 plus Z2, you mean A plus B, I plus X plus IY, which is A plus X plus B plus Y outside of I. Yeah? Simply mean the sum of the imaginary elements times I plus the sum of the real elements times nothing, times 1. You can also multiply them. You simply cross multiply it. Division, you have to realize the denominator. This is slightly more complicated. Alright, so Z1 minus Z2, you multiply it by 1 in the form of its conjugate. Okay, the conjugate is simply multiplying the imaginary aspect by -1. What happens there is you get a real denominator made up of this, and then you get a much more complicated numerator. The algebra is not important, you should be able to do it yourself. Again, diagrams. Again, diagrams. Now, complex numbers cannot be bigger in the same way that real numbers can be bigger, because there is a third dimension in the plane. No, a second dimension in the plane. And the number line looks like this. Therefore, it makes sense that the imaginary axis is added onto the number line. So this would be your standard real number line, with negative infinity through positive infinity with 0 in the middle. And this would be your imaginary number line, which is simply the coefficient of I. Now, take Z1, for instance, which is here. The bigness of complex numbers is denoted by the absolute value to Z1, simply notation, which is the distance from the origin. Okay? So if Z1 is equal to 5 plus 3i, using Pythagoras' theorem, you would know that this is 5, this is 3, therefore this is 5 squared plus 3 squared, which is 34 squared. Root 34. The distance between 2 points is just the same. It will be the absolute value between Z1 minus Z2. And what that will give you is this distance here. Whether you do Z1 or Z2 first doesn't really matter, you just get the absolute value of it. Distance is constant. Now, some simple rules of complex numbers. 1 over I is simply equal to -I. Just remember this. Prove it by realizing the denominator. Any complex number times its conjugate is its coefficients independently squared. Shown above in the realization of the denominators. Now the addition of its conjugates will simply be 2 times the real aspect of Z, and the subtraction will be 2 times the imaginary aspect of Z. I'm not going to prove these, it's simply the arithmetic. Okay. algebraic expansion can also prove that the conjugate of z1 plus z2, any two complex numbers, is equal to the conjugate of their respective values. Likewise, conjugate of z1 times z2 is equal to the product of its respective conjugates. Finally, triangle rule. Yeah. This is A, this is B, this is C on a triangle. Doesn't really matter which one is A, which one's B, which one's C. You can always comfortably say that A is less than or equal to B plus C. Simply put, any one side of the triangle is going to be equal, if it's not really a triangle but a line, or less than the sum of the two sides of the triangle.